Okay, so I'd like you to get a little bit comfortable with the problems we're going to look at. These are called projectile motion problems. And again, they're really based on this concept that the horizontal motion and the vertical motion are really separate from each other. So it comes down to three equations, but really only two of them that we're going to use in these problems. You'll notice one of them, the horizontal distance equation, is right here that we just wrote down a moment ago. Distance is velocity times time. Vertical velocity does change, as this says, but we're not even going to need it just yet. But vertical position then has a square in it. It's 4.9t squared. So on these problems, what I'd like to help you think about is just a couple of strategies. Let's take a look at one of them together, and let's think about what might help it to be pretty straightforward. As you look at the problem, I would encourage you to read and decide what you're seeing. So we have a cat running and jumping from one rooftop to another that's 5 meters away and 3 meters below. 5 meters away, 3 meters below. And then calculate the minimum horizontal speed with which the cat must jump off the first roof in order to make it to the other. What? I need a picture. All right, so here's a roof. 5 meters away from that roof is another roof that's 3 meters down. How about something like this? So we know that the distance in between these two roofs is 5 meters. And apparently the distance down from one to the other is 3 meters. There we go. So that's the information that we're given. Things that we're given: 5 meters and 3 meters. Now you'll notice we've decided what those are called. This is a horizontal distance. So this is dx. And 3 meters below, that looks like an x, is a vertical distance. So this is dy. So we have dx and we have dy. And then you'll notice the problem describes the question we're after. Calculate the minimum horizontal speed. In other words, v for velocity, x for speed. So this is the thing we're trying to find. Excuse me, v for velocity, x for sideways. So we're trying to find vx. We know dx and dy. Well, we need a tool that has a relationship that ties these three things together. And that would be one of the two to use. That would be the horizontal distance equation. And in this case, we don't know Vx, but we do know dx. Oh no, we don't know the time. Well, don't worry. If you get stuck, then you switch and grab the other equation. This person has already rearranged this equation for us. It says t squared equals dy over 4.9. Where did that come from? Well, you know the vertical distance is 4.9 t squared. And if you take that and rearrange it for t or t squared, of course, you can divide both sides by t squared. That's what happened. Anyway, so we started out with the equation that does horizontal, because that includes what we need. We got stuck, so we had to use the other one, and then we came back. What's the solution to the problem? So we put them in. T squared is dy over 4.9. Hey, and we know the 3 meters is dy and the 4.9. So we have a time, or at least t squared, that then allows us to figure out, hey, here's how much time is in the air. Well, once we know how much time is in the air, then we can go back and solve the original problem, because we now know the distance, horizontal, and we know the time. So we take 5 meters over 0.78, and we've got ourselves a speed. Hey, here's the deal. You just have two equations to use, and the key is we need to be able to use one, and then if we don't have everything we need, we switch and we use the other. So again, these two tools are the keys for what we're doing. I'd like you to try these problems, take them for a spin, see how they go, stop in for some help if you need. We'll keep working on them Thursday, and we'll see if we can make some good progress. Thanks for digging in. We're almost there.